Hello, everybody. Well, after the keynote, this is the first talk of the day, so hopefully this is a good start to your GOTO experience. I love being part of the GOTO family, so hopefully you're going to have a really good conference today and talk about what we're going to be talking about today. So picture a world if you can run your code and other applications seamlessly in the cloud without having to worry as much about scale. Things just scale up and scale down as you need them without you having to lift a finger. Some of you may be thinking, that's crazy, Julian. That's only things you can do in the future. But actually today, this is what you can do when you build with serverless applications on AWS. Now, obviously, I work for AWS, so we're going to be talking about AWS services today. But serverless is a bit of a bigger industry term, and a lot of the things you're hopefully going to learn today can be applicable to other architectures or other places that you're going to be running your code. So what is serverless, and sort of how does it link with event-driven architectures? Because we are talking about EDA today, and the two match very well together. Well, the idea of serverless is actually all about focus. It's about getting your developer teams to focus on running your applications and your code rather than thinking about infrastructure and scaling and clusters and instances and all these kind of things. So you can see the sort of the diagram, the things that AWS would look after, or a cloud provider would look after, or a serverless provider would look after, is a whole bunch of things that you don't then have to look after it. And you can focus on your business logic, maybe your APIs, maybe your integrations, maybe your data, the things at the top of the stack, and you don't have to worry about all the infrastructure underneath, the servers, the networking, the storage, all the things. I come from an infrastructure background, and I've plugged enough cables in racks, and I've got enough blood on my fingers from all the cage nuts and everything that I used to work with. And those days, luckily, at least when you're in the cloud, are gone, but also when you're looking after the new abstractions of storage and networking, when you use serverless, you can let a cloud provider look after that on your behalf. Now, I mentioned before, there are a lot of different serverless services. This is just a few of them. Previously, when we talked about serverless, it was often just about compute, which we are going to cover a lot about today. But there are lots of different serverless services, from storage and workflows and analytics and various databases. And the idea is that you can just connect to all of these services. You can use them as they run on AWS. And they've got a whole bunch of sort of cool properties that you, as I've mentioned before, don't have to worry about the infrastructure to manage or the operating systems or a lot of the patching, all these kind of things, and you get to focus on small kind of things. And as the industry is moving with AWS and other cloud providers and other kind of services, things are becoming more serverless. There are more applications that are coming out, more services that you can run that you can just consume in a serverless way. And so serverless has been running for a number of years. It's not a new industry term, and so when people sometimes think that serverless is a fad or is it kind of the future, it is really the way that many applications are just built by default. And this may be applications that you run, or there may be applications that you consume that are running on the cloud that somebody else is also running in a serverless way, maybe as a SaaS model. And one of the cool things about serverless is the way that utilization works. And if you're thinking, if you're running something traditional or on-premises, you've got this sort of scaling way that you need to provision the capacity that you've got. And sometimes if you're going to have overcapacity, if you're using traditional on-premises, where something's not happening on a weekend or an evening, but you have to provision that capacity in case it comes sometime in the future. Then, when you're moving to the clouds, or you're having some virtualization technology, which allows you to in a more agile way, spin up virtual machine instances or even container instances on demand or some kind of scaling thing, yes, you do have a better way that you can handle this capacity, but you can see the sort of red peak, something's going to catch you out. You're going to have some unexpected load, something is going to trip you up, maybe a sale that happens or some business process that happens that's unexpected, and you're going to be disserving your customers by not being able to handle that. And when using serverless technologies, that problem becomes our problem. It becomes AWS's problem that we can handle that scale for you. And so you can see the sort of nice graph that perfectly matches your use. And for most scenarios, you really don't have to manage that. We're just going to do that on your behalf. And you don't get caught out having a little horrible, ugly red line where you couldn't serve your customers. And some people think, well, certainly serverless must only be a hobby toy. Not at all. Service is at massive scale. Now, obviously, as a big cloud provider on AWS's behalf, Lambda functions, which we're going to be talking about, just running your code. We process tens of trillions of these requests every single month. Amazon Event Bridge is an event broker, trillions of those as well. And ECS is one of our container services, and billions and billions of tasks that are being done. So, these are massive, massive, huge services at AWS which you can take advantage of, and you don't have to worry about the scale underneath. And so one of the sort of big things of why to go serverless is, sure, there's no infrastructure to manage, and maybe you don't care thinking, well, I don't look after infrastructure anyway. So the bigger picture is, well, why do you want to go serverless? And from an organizational perspective and a team perspective, and as a developer, if you're a developer sitting in the room, the quick thing is you want a faster time to market. You want to try things out quickly, you want to iterate quickly, you want to maybe doing, working in an agile kind of way, and if you can go from prototype to production really quickly, that's going to be better for your business. You've got an idea on a Monday morning, or you've come to GOTO, you've seen some great talks, come up with a great idea, and to be able to actually implement that in your organization, if you're going to have to request resources and fill in tickets and do all that kind of thing, can take a long time. While if you're using a serverless approach and AWS is looking after a whole bunch of things and you can concentrate in your code, this sort of flywheel can happen much quicker, and that's what people love about it. If you're a developer, you just want to get things done a little bit quicker. So today we're going to talk about serverless compute. There were a lot of other serverless services with storage and integrations and workflows and kind of things, but today it's all about compute, because I know we've got lots of developers in the room and you've got code to write. You're excited about what you can bring with your innovative code. And the way to think about compute and serverless is there is this sort of spectrum. And as we've been speaking about, what you manage and what you don't manage is on the y-axis. And Amazon EC2 are our sort of virtual machine instances that you can then rent from the cloud, and then you can install anything on that. So any traditional application, from databases to messaging services to Kafka to RabbitMQ to a web service to anything, your custom applications. That's what you can run on an EC2 instance. And of course, that's not very opinionated, because you can run anything on that. It's really easy, but obviously you've got to manage a lot more. You've got to update the operating system. Maybe you've got some frameworks installed on there that you need to update that. Maybe you've got a web server on that you need to keep up to date. So you take on more of the operational tasks, but it does give you a lot more flexibility. And as you head up, you've got some more serverless services that you introduce. So ECS on Fargate is a way of doing serverless containers. We're going to go into that. And that means, well, you've got a little bit less to manage. You don't actually need to manage the physical instances or the virtual instances, the virtual machines, just containers that we will run at whatever scale. It is slightly more opinionated, because you can't have all the breadth of all the virtual machine instances, but surely that's going to help you if it's going to be able to fit into that, and you're going to be able to do some cool stuff. Then sort of top on the right is Lambda. Well, Lambda, you've got way less to manage. There's no, the frameworks we look after for you, the way that events get into your function, we look after you. You can poll from Kafka, for example, or RabbitMQ. We handle all that for you. So AWS is going to handle a lot more for you. And it does mean it's going to be a little bit more opinionated in terms of how the service is actually going to run. We're going to go into some of those opinionated things, which are some actually cool constraints which you can work in, but it's something to bear in mind. So you sort of have a decision tree, what service you're going to be able to take advantage of, and you're going to be able to hand over more responsibility that we can do all the distributed computing stuff, and you focus on your code with Lambda, all the way down to picking your individual compute instances with something like EC2. So when we talk about serverless functions, we are talking about AWS Lambda, which is a service that we run, which you can use to run code in the cloud. And it's sort of a simple sort of pathway that how Lambda functions run. You've got a Lambda function in the middle, which can be run, which you can use any language. We've got some managed runtimes for things like Node, Python, Java, C#, and things like that. And we actually maintain and keep that runtime up to date. So there's no patching Node, there's no doing anything in Python, for example, or Java. They just get upgraded automatically, and off you go. They don't get upgraded between the major versions. So if you're using, say, Python 3.11 and Python 3.12, we're not just going to upgrade that for you, because that's going to freak out all the developers in the room going, you must be crazy. A Python or a Node version jump is going to be crazy, but within Python 3.12 or Node 20, for example, we will do the updating on your behalf. We'll also update things like the AWS SDK. So again, something else you don't have to look after. And so that's your function code that is all going to run. We look after the framework. You then look after your application code, and you can just package that up. But then, how does a Lambda function actually run? Well, it runs based on what's called a trigger. And the trigger is an event which causes a Lambda function to fire off. And this can be a data state change, so it could be an update to a database, which could do a CDC update for a record. You could run your function behind an API endpoint. I'll show that shortly. And so you just hit the API endpoint. It's going to kick off your Lambda function. Or maybe you're going to process something from a queue. It could be RabbitMQ, it could be Kafka, it could be a whole bunch of different streaming technologies, and that those events or batches of events are just going to go into a Lambda function. It's going to run your custom code, and then what you do within your custom code, as you would do with any normal application. Maybe you're going to read and write from an external API, or you're going to put it into a database, or you're going to send it to some other messaging service, or transfer it somewhere else. Literally up to you. The sort of imagination you have to run your code in the cloud, you can just do that with Lambda. It's just normal function. It's just normal programming code that you're going to run on the platform. 3 different ways you can invoke Lambda functions: synchronous, asynchronous, and poll-based. So a synchronous one, think of it behind an API. So you've got an API gateway, for example, or something behind a load balancer. You can stream responses out of that as well. Simple request response if people have been building web applications for ages. Asynchronous is super powerful, particularly with Lambda, where you can run asynchronous background tasks. And this could be consuming something from a queue, as I've said before, or polling something else from a database, or a CDC change, whatever it is. And basically the difference between the two is Lambda runs an internal queue, dumps those events on the internal queue, and Lambda handles sending that to your function code. And then the poll-based is actually that sort of polling from the databases, and actually we manage a poller on your behalf. It's entirely free, so if you're getting something from a Kinesis stream, which is a streaming platform we have, or you're using Kafka or RabbitMQ or something like that, we will actually run the poller on your behalf. You don't have to have an EC2 instance or a container doing the polling. It's all free. You can filter and do a whole bunch of things with that, and then send your code onto your Lambda function to do what it is. Lambda functions are all really secure. Each invocation of that Lambda function runs in a secure micro VM, so it's not quite a container. It's actually, I think, more secure and more isolated than a container, but you can think of it as it's got the fast startup time of a container, but with even more security involved, and your function is not shared between any other function in your account, let alone other customers or anything else. So you can be really confident that this is a really secure way to run your code. You can actually package your Lambda functions in 2 different ways. One is as a zip archive. You literally just grab all the files in your Node.js or Python application or Java application. You zip them up, upload them into the cloud, and you can run your Lambda function. But also what you can do is that you can actually package your Lambda function as a container image. So you can have a normal Docker file, and you just decide, I need to install some software with your normal Docker file things. We've got some base images that you can use. So if you've got Node, Python, or whatever you need to use that, you just use our base image, which includes all the functionality to make Lambda work. And then you build up your Docker file as you would with any other application, and you just Lambda function can then be generated from that Docker image. So that's pretty cool. If you can then use the same tooling or the same build processes, CI/CD pipelines. Just a really flexible way to be able to sort of combine the container world and the functions world in the same packaging format. Oh, there's actually a container image. So you can see I'm just pulling the Node.js version 20 from our ECR, which is our Elastic Container Registry. It's like Docker Hub, just our AWS version. I'm going to copy the app.js and the package files. I'm going to do an npm install, and then the CMD file just says, well, when you do run this function, go into the app file and the module called the Lambda handler. So that's a simple Docker file to run your Node.js application on Lambda. One of the cool things about Lambda is how it scales. And as we showed the graph earlier, it scales as per usage. So if you have no usage, you don't pay anything, it doesn't need to scale. As requests come in, hopefully you've built a really cool application that people actually want to use. The scale is going to ramp up, and Lambda is going to be able to take advantage of that. And you can see here a sort of timeline goes from left to right. When a request comes in for your Lambda function, maybe this is going to be behind an API, it's going to run some initialization code, and this is code that you're going to write. Maybe it's going to be getting an API key or a secret from somewhere, or setting up some kind of connection, and then it's going to then run your invocation of your function, which is going to be maybe taking that event object or something behind the API, writing something to a database, or gathering information from a third-party API, whatever your code would normally do. And then because that initialization code is already run, we don't need to grab those secrets again or grab that API key. We can just reuse that in subsequent invocations, and your invokes can come back in. If you do then have another request that comes in for your Lambda function at the same time, so you can see request number 3 comes in, well, that first what's called invocation or execution environment is actually in use. And so it actually spins up another execution environment, and the process happens again. And this can go up to actually quite ridiculous scale. So Lambda functions can scale up, scale down to 0 if there are no requests coming in. You can see there's a shutdown process that happens automatically at the end. Your code's not running, you don't pay for anything, is really efficient. Lambda functions can run for up to 15 minutes, and so that's an architectural decision to think of, but it's super useful for, web requests. You think how short are many web requests, or if you're batching things up and you're doing some processing, 15 minutes is actually a pretty decent amount of time. A Lambda function can have up to 10 gig of memory and 6 virtual CPUs. So that's quite a bit of compute time you can take advantage of. And then let's have a look. Should we build a Lambda function? We can see how that actually works. So let's see. Why don't we just create a Lambda function? Anyone want to pick a programming language? Node, Python, Java, anything? No? There we go. I heard a Node. Did I hear? I heard a Node and a Java. We'll pick Node. It was on over here. But you can see we've got a whole bunch of different languages. I can use C#. And this is just languages that we maintain and keep everything going. So I'm literally going to create a function. Please correct the errors above. I need to give it a main name. That would help. Hello, GOTO. I'll call that, and we will create a Lambda function. So this Lambda function takes a few seconds to create, and it is going to just send me some, do some code, which is literally what's the code going to do? Literally code is just going to say hello from Lambda, so I'm going to say hello from Lambda via GOTO Amsterdam. So I'm going to deploy that, and that code is now deployed as part of a Lambda function. I haven't needed to install any software, I haven't needed to do anything, Node is just over there. I can actually test this Lambda function. So I could send it an event JSON or just nothing. I can leave that over there, save it on my test event, and I'm going to test my Lambda function. And there we go. Hello from Lambda via GOTO Amsterdam. Now, what I can also do is, why don't I just connect this to an API? So I'm going to use API Gateway, which is one of our API services, and I'm going to do an HTTP API. I don't need any authentication. I could use a JWT token. Off I go. I'm just going to now connect this to an API. There we go. I now have an API, so I can view this API endpoint, and there we go. I can just zoom in a bit. Hello via Lambda via GOTO Amsterdam. Now, I know you think that these are always canned demos, so what I'm going to actually do is I'm going to, you can even try it out yourself. So I am just pasting this API into a URL shortener, and what I'm going to do is, where's my QR code? Sorry, I'm flicking between some slides because I've. So if you actually go to this URL, hopefully I've pasted in the correct information, and you should be able to see that. Can you confirm you're going hello from Lambda at GOTO Amsterdam? Good. Okay. So now you are scaling Lambda up. I didn't install anything. I didn't tell how many people were going to be in the room over here. I didn't do anything. You're just scanning the QR code via your phone, and a Lambda function is going to scale up to handle whatever request it's going to be. So that is the start. But now I actually want to talk about Lambda function scaling, but I'm just going to kick off a demo that's going to happen in the background. So that actual URL endpoint, I've got a slightly different one, but anyway, it works in the same way. There's this cool little tool called Hey, which is going to hit like crazy this API endpoint. I'm going to hit it with 10,000 requests every second for 5 minutes, and I'm just going to hit that off. So that is going, that is doing the same kind of thing. I think it's hitting another Lambda function I'd pre-created, just in case the demo gods weren't behaving with me today, but we're going to show how Lambda really scales. So we've got, I don't know, a certain number of people in the room. You've scanned the QR code and you've brought up a Lambda function. But Lambda functions can actually scale, really into huge amounts. And what happens is, if you started off with a Lambda function now, if we had 1,000 people in this room and they all hit that URL endpoint, it would just work automatically. And then Lambda allows you to scale up to another 1,000 every single 10 seconds. So you can imagine if you're starting from complete scratch, you can just hit 1,000 Lambda functions, can run off, and then you can get another 1,000 requests in 10 seconds. And obviously, this is super useful. You've got varying traffic patterns. You don't know who's going to be coming to visit your website. Off they can go, and they can just take advantage of the scale. It's all going to scale automatically. Now, that 1,000 concurrent executions every 10 seconds may seem a bit limiting to you. You can increase that as well. You can increase it in one way. There's a service, a feature of Lambda called provision concurrency, where you can say, well, actually, at 9 o'clock tomorrow morning, I have a sale coming in. I'm going to have 100,000 requests that are going to come in, and you can pre-provision Lambda to be able to handle that load. So those 10 seconds are built up before the 9 o'clock. So it's a way you can configure your scaling. Now, previously, before the scaling, it actually took a lot longer. So you used to have this concept called burst concurrency, and you could then scale sort of 500 Lambda functions every minute per the accounts. And sort of, it took a bit of while. It took a bit of while. So that test I'm doing when I'm doing 10,000 requests for a Lambda function would take about 12 minutes to eventually get up to there. Not the end of the world. If you've got 10,000 sustained requests hitting your web application, that's a pretty busy website. Most websites are probably running, I don't know, 100, 200, 300, even if they're busy every second. This is up to 10,000. But that would take 12 minutes. So we think we could certainly do better. So what we did actually is we sort of changed that whole scaling arc. And instead of having this stepped graduation of 500 every minute, we just have done this now 1,000 every 10 seconds. And that means instead of taking 12 minutes to get up to that scale, it's 90 seconds. So literally within 90 seconds, you can have 10,000 sustained requests. This is an amazing, quick way to get a huge bunch of compute capacity in the cloud. So that demo is still working. Let's go back. Let's see what's been happening with this. So this application is scaling like crazy. I have some metrics that are running over here, which is not showing anything, which is unhelpful. Oh, there we go. So we have sort of two lines over here. The blue line is showing my concurrent execution. So we can see when I started that demo, I've got 2,000 running, so obviously it just caught up with over there. And you can see as this is scaling up 4,000, and we should be handling up to 8,871. We'll get up to 10,000 pretty shortly. It's within a minute and a half. And this is literally a live function scaling up to handle those 10,000 concurrent requests. Now, when we did start, obviously, we were sending 10,000 requests, so there were going to be some initial throttle. So for the first 90 seconds, we're expecting to see some throttling. This is that orange line. And you can see here, we now hit up to 10,000 requests, and the throttles are 7. OK, so it's going, but that's going to go down to 0. So within 90 seconds, we've been able to hit 10,000 sustained requests to this website. And I could keep this going literally ad infinitum. It would never shut down. It would just handle 10,000 requests all the time. And that was going from a standing start. If I decided that I needed 10,000 requests to happen in 5 minutes, I could just configure that little toggle and say, in 5 minutes, make sure you're ready, and Lambda would do the trick. So a really easy way to, as you saw the Lambda function I created, I didn't configure any scaling. I didn't need to install anything. I didn't need to scale this out across availability zones for availability. It didn't need to do anything. I just threw the code at Lambda, and off it went and scaled up as high as we needed it to do. So that's on the Lambda side. So Lambda, scaling per use, really convenient way that you can run code in the cloud. We have all the things that are just installed, really easy way. The other way to do it is with serverless containers. And serverless containers is a different way to run containers in the cloud. And previously, people think of serverless and containers. That's a strange sort of way to think together. But actually, it works really well. And we've got two services that work in interaction with each other. One is Amazon ECS, and one is AWS Fargate. Now, Amazon ECS is the control plane. So this is the way that you're going to configure to run your containers in the cloud. It's absolutely free to use. So this is a free container orchestrator in the cloud. There's no cluster versions to manage. There's no data store. There's no anything you need to handle in terms of replication or anything. It's just a service you run in the cloud to handle your containers, and it's going to decide where they're going to run. And where they actually run is the data plane. And this is a service called AWS Fargate. And this is just a managed serverless data plane. There are no instances to manage. There's nothing you need to scale or anything. And you just pay for what you need. And so a sort of nice serverless option that you don't need to worry as much about the infrastructure. We'll handle that for you. So for ECS on the container orchestration side, ECS, as with a lot of other AWS services, is deeply connected with AWS. A lot of different services and third-party things. So if you're using, on the observability space, particularly, if you're using, Fluentbit, Prometheus, Grafana, all these kind of things, for all your other container workloads, bring them along. We'd love to, use that with ECS and with Fargate as well. So lots of integrations with other AWS services. And just the way ECS is put together, you basically have tasks, and these are one or more containers which you specify some compute capacity, and a task is going to run your container. A container, as with all other things, is just a normal OCI Docker file. Obviously, you're not using Lambda at this stage, so you may need to install Node or Nginx, or you may need to install some more services because you're going to running in a container construct rather than a serverless function. And then a service is made up of multiple tasks, so identical tasks. So this would be your front end of your application, maybe, which is load balanced, and you're just going to run these containers. And then you can also cluster them together for a whole kind of grouping. And under the hood, you can actually use various compute options. So you can use any EC2 option. You can use EC2 Spot. So EC2 Spot instances are ones where you could just borrow from AWS for a short time. It costs way less. But the thing is, if we need them back, we will give you a minute or two's warning to say we'll have them back. But you can save a lot of money using EC2 Spot and Fargate Spot as well. So it's a quick way to rent cheap compute capacity in an ephemeral way. So the difference between ECS and tasks and services, well, tasks are sort of on-demand workloads. So we're talking about event-driven architectures today. I'll be showing a demo shortly, and this is one of tasks. So there's a task scheduler component, and you say, excuse me, ECS, I need to run this container. Here's a container I need to run. Off you go, and you're going to go and run it. You can use it for batching, just a way to run it. And then services are sort of for long-running applications. So maybe this is going to be a front end, or you've got a Polar, or you've got some kind of service that needs to have a whole bunch of containers up and running. And so you're going to run a service that needs a bit more of sort of that the service is going to run, that if a container dies, it's going to bring it up again. It's going to handle it across multiple availability zones. And so service is for a long-running service, and a task is for an individual task. Task definition has got information over here. You can see, it's got networking information about where you're going to put the logs, what port you're going to expose it on, and some memory configurations. But task definition is just some JSON. So that's on the ECS side for sort of controlling it, and then on the Fargate side, well, this is actually the sort of serverless containers under the hood. And actually at AWS, we manage this on your behalf. So we actually dynamically provision an instance. So it is actually an EC2 instance behind the scenes. You don't never see it. You don't even know what it's called or what it looks like. We will look after that for you, and you just define the resources being the CPU and the RAM. So you tell us what CPU RAM you need, and it's going to share that and manage all the containers in the task for running that. In terms of patching, well, this is where some of the differences between something like Lambda comes up, where with Fargate, AWS is going to manage all the hosts and the infrastructure, but any of the code that's going to be running in your container, you're going to handle that. So that is going to be the runtime, or the libraries, or the SDKs, or anything within inside your application container you're going to look after. In terms of load balancing and ingress, another difference. When Lambda, you saw when I added that HTTP endpoint, I didn't have to configure or handle any of that. It was just another service I connected. When you're using containers and you're using Fargate, you need to manage some more of the network infrastructure, and so you will run a load balancer in front. And it's a sort of port and socket mode, so you're going to, on that load balancer, you're going to say, port 443 or port 80 or whatever port's going to be coming in, and I'm going to then distribute that between my different applications. For a service, for example, that's going to run on my different compute instances. So again, it's not as serverless as Lambda. You are, when Lambda's handling all of that ingress for you, you're going to do this a little bit on your behalf, but people want to do this on their behalf because they have very specific needs that Lambda maybe doesn't satisfy, and so this is a way that you can sort of have the best of both worlds. In terms of the scaling, well, Fargate doesn't scale in the same way as Lambda. These are for services that you want to have a bit more intentionality of how things are going to scale. So Fargate under the hood is going to manage the EC2 instances. We'll make sure there are always EC2 instances available for you. But then you decide how many containers you're going to need, and you can do that for a number of ways. You can use auto-scaling to scale them up and down. It's not going to be as fast as Lambda, but it's certainly going to be as responsive as you can spin up a container. But you can use CloudWatch, you can use Prometheus, you can use literally any metric that you have in your business to say, you know what, I need another container spin up, or I need a container to spin down, and you handle the scaling of that. And you just basically go to that service and say, I need 20 containers. In an hour, I'm going to need 40, and nighttime comes, and I only need 2 to keep it up and running. So you handle the scaling as part of that. So we're talking about event-driven architectures over here, and generally, I think people understand event-driven architectures really well with Lambda, because they know that an event comes in, it could be an HTTP or a database change or a file change or something, it's going to kick off a Lambda function to do something. That a sort of event-driven pattern is very applicable. But people often don't think about, well, how can you do event-driven architectures using containers? And I think event-driven architectures is a really powerful way to build applications, because it allows you to decouple different parts of your applications. You can then manage scale differently. You can use the best service for the job. You can run the best container for the job. So instead of having one huge container that's got all your application artifacts and everything in one container, you can split them out maybe into some different sort of microservices, and the microservices need to communicate via different ways, and using an event-driven architecture is a very effective way to do that. And I know Sam Newman is here. He's literally written a book on microservices, and he talks a lot about asynchronous applications, and that's a way that you can use event-driven architectures. So 2 ways you can use event-driven architectures in the container world, and one is having a task that fires off when an event happens. So for example, over here, there's a S3 bucket, which is our object storage. So someone puts a message on an S3 bucket, and that's going to basically trigger an event rule, which is then going to kick off an ECS on Fargate task to do some processing, and your code is then put something on another Amazon S3 bucket. Now, the reason you would do this in a container as opposed to a Lambda function, because a lot of this functionality is built in with Lambda, is you've got more flexibility. So maybe it's going to be a cost concern. Maybe you have a workload that's going to run longer than 15 minutes. Maybe you need a GPU instance. So you're going to do some machine learning inference or maybe some cool generative AI. You're going to be able to run that in a container, but still use the event-driven model that as soon as a file is uploaded, you're going to be able to then process that file. So maybe you're going to do, to have a huge video file, for example, and it's going to take it longer than 15 minutes, needs a GPU instance to do something on it. Well, this is a great way you can do it in the container world as well. So that's on the task for the individual tasks. You can also use event processing in containers. So in this example, we have an ECS service, which has a number of containers, and they're going to be draining an SQS queue. So SQS is one of our queuing services. This could be RabbitMQ. This could be managed MQ. Any kind of queuing service, and you can manage this as a service, multiple containers, very high throughput to be able to drain an SQS queue, and for high-frequency events. So I actually do have a demo to show how we can do some file processing with serverless compute, and how you can actually use both in the same application. Because when I spoke about earlier, when there sometimes was this, oh, do I use serverless containers? Do I use serverless functions? Surely they're at odds with each other. Well, the reason is serverless functions are really useful, serverless containers are really useful, and you can actually use them together in the same application. So I have an example over here of a sort of file processing pipeline where people can upload videos and they can also upload images. Now, the images are going to be really quick to process because they're just an image, but a video, you can imagine, video takes a lot more processing to happen. So what we're going to do is we're going to a customer or some business process is going to then upload one of those videos, and that's going to land in our S3 bucket, which is our object storage. And that is automatically going to kick off an event bridge rule. And I'm going to cover quickly what event bridge is, but ultimately it's just going to say, oh, this file has happened. I'm going to grab the information about what that file name is, and then I'm going to send it to a workflow automation service. I'll cover that shortly, but the step functions is just going to handle the workflow, and what that actually is going to be used is to say, when this file comes in, what is the file? Is this file an image, or is this file a movie? So if it's a video. So if it is an image, I'm going to use Lambda because I know it's going to be the most efficient way to run that. And if it's going to be a video, I'm going to use Fargate because I want to use a container because it's going to run longer than 15 minutes. And then ultimately, the code's going to be very similar, and I'm going to send that on to an S3 bucket. So let's have a look at, before we have a look what that looks like, I just want to let you know 2 of the services. So Amazon Event Bridge is an event router that runs in the cloud. Also ridiculous scale, it's very serverless, there's nothing you need to run, nothing you need to manage, and nothing you need to patch. And this is a great way to build event-driven architectures and a great way for microservices to communicate with each other. A service will put an event on the event bus, and other services can react to that. And the way they react to that is just pattern matching on anything that happens in that event. So you can look at the metadata, you could say, For example, is this from this particular microservice do something? Is this value greater than something? Is it less than something? Is this value and this value all come together in a whole sort of matrix of different capabilities? We'll then route it to that service. And then you can route it to a Lambda function, you can route it to a container task, you can route it to or send it to an API endpoint on the internet. Literally, there are so many different integrations you can do, and it's a really powerful way to connect applications together. In terms of what can put things on the event bus, sort of 3 different buckets. Your own custom applications, create an event, put it on the event bus, super powerful. All AWS operations automatically put events on an event bus as well. So this is super powerful. If you want to react to when an EC2 instance was created, or you're doing something in any AWS service, that's going to generate an event, and you can react to that. And then the other sort of third part of EventBridge is there are native integrations with SaaS partners. So if you are using Zendesk, or you're using Datadog, or you're using, I think there's sort of 30 or 40 different partners, and they will automatically put events on your event bus. So you're using a ticketing system, say with Zendesk. If a customer puts in a service request, that service request ID is literally going to appear on your EventBridge event bus, and you can build an event-driven architecture to handle that. You don't need to manage that connection. You don't need to run a webhook. You don't need to poll Zendesk. You don't need to do anything. It just happens sort of automatically, which is cool. And then step functions is the other part, and this is a workflow orchestration. So this is where you compose infrastructure as part of state machines, and it's all going to run within a microservice. And this is a really cool thing if you're going to use, Saga patterns or transactions or these kind of things where things need to happen in a particular order. So you've got, think of a bank example. You want to transfer money into a bank, and it needs to be taken from one account to put into another account. You want to make sure that doesn't happen twice. You need to be able to recover from that, all that kind of things. Airline bookings, you need to book a seat, do a loyalty card, all these kind of transactions that need to happen in a particular order. Step functions is a great way that you can do that, and we're going to use that in this demo shortly. So, and these 2 services work really well together. So orchestration, often within a microservice, tightly bound workflows that need to happen together. You can use step functions, and then EventBridge to sort of choreograph between the 2 where you've got microservices connecting. So let's look quickly at the serverless containers in action. So often people think with containers, well, I have to pay for things all the time because I need to have the containers up and running. But in an event-driven way, we don't want to pay for things that aren't happening. So at the moment here, we can see I have no tasks that are running. I have no services. I have no tasks for this application. So literally all I'm going to do is I'm going to copy a file. So I'm just copying a file from one S3 bucket to another S3 bucket, and that is going to kick off this workflow. So you can see automatically over here, I now all of a sudden have an ECS task. So I didn't do anything, I didn't pre-provision this, I didn't create anything, just the event-driven architecture part of the side has just kicked off this ECS tasks. But what has kicked that off is the step function state machine. So if you can see I have a step function state machine that's kicking off here, and you can see step functions has this really cool visual workflow that you can go through, and it came over here, and the first step of this workflow was to check the image size. So this image, if an image is particularly big, it's actually an incorrect label. This should actually be whether it's going to be that image or it's going to be the video. And that choice state within step functions is configuration, is set up as part of the configuration to say, well, because this is going to be a video file, I'm actually going to use ECS to run it because I know it's going to be longer than 15 minutes. If it was a video, I would have just used Lambda. So within the same application, I'm using containers, and I'm going to use serverless, and I can dynamically pick just basically based on a file extension. I just say, is it .mov or is it .jpeg, and do that. And so this serverless container is going to spin up. I think I've even got the code. Where's my code? Yeah, so I mean, this is just code that's running. For the serverless side, you can see this is a Docker container for the container. I happen to be using Alpine. I need to install FFmpeg because that's going to do kind of stuff. And I've got some application code. And this is, I think, the application code that runs in the container. And you can see it's going to grab stuff from the input bucket. It's going to run FFmpeg, and it's basically going to do whatever I need to do on within this movie file, and then upload the file to S3. And actually, I think this is the Lambda function. Very similar code. I am just running this main function. It was basically to show you that the code that's going to be running in your container and the code that's going to be running in your Lambda function can be really similar. So I'm not going to bore you to tears by watching the end of this task running for more than 15 minutes, as it's not going to do anything. But yeah, really useful capabilities to be able to use step functions and Event Bridge in an event-driven architecture way. In fact, I'll show you quickly what the state machine looks like, and you can see how we can create the state machine. So you can see really nice and visual, really great way to build a workflow. If you're working with business people, how cool is this? Instead of having to show them lines of Python or lines of Java and say, does this workflow or does this business process match what you were expecting? And I know the business people I've looked at are like, I don't know, I'm not a coder. Show them this, this visual representation of it, and it's a really easy way that you can understand what's going on. I've got a choice state, check what's going to happen. Decide between running the container or running the Lambda function, and then at the end of it, I'm going to also, send the message onto the Event Bridge event bus, because maybe a downstream service is then going to react to this, and it's going to maybe, upload it to a website, or it's going to use some AI tool to generate text-to-speech, or various kind of things you can do with integrating with other AWS services. So, you may be thinking, Julian, you've been bamboozled me with enough. There are lots of options. I appreciate that. Well, how do you then choose which compute option you're actually going to, which is the right one for your application? And so there are some architectural differences between the two different approaches. Lambda we talked about when you've got these managed triggers, so the thing that is going to cause the Lambda function to run, that is going to be managed, and AWS is just going to manage that on your behalf, really easy to do. And also the runtimes are going to be updated, patched, they're going to be looked after by you. You don't need to do anything for you. Containers, you have the flexibility. You can run your own custom code, you can run your own web services, your own polling logic, your own database instances, anything you need in a container, you can run that for yourself, so you've got the flexibility. But obviously there's a trade-off for that it does require some more maintenance and so management and orchestration to run that. But if that's what you need, perfect. In terms of the resource considerations, well, I mentioned before, Lambda functions can run up to 10 gig of memory. So the cool thing is you can have a really small function. So lots of people, if they're running web requests, they don't need a lot of compute power. So you can run from 128 meg of memory all the way up to 10 gig of RAM. That's all you need to configure. By default, it's going to proportionally allocate you CPU resources and network resources. And so, yeah, just something else you don't need to consider. Lambda functions can run for a maximum of 15 minutes. So with that computing power, that's only a single Lambda function. As you saw with the scale out, you saw we had 10,000 requests. Even when the people in the room were hitting that QR code, they were adding multiple Lambda functions. So each Lambda function that's going to run can run for 15 minutes. Each Lambda function up to 10 gig. So Lambda's big power is all that scale out. I ran 10,000 requests. That's a lot of computing power you can use. But it also has that single concurrency. With containers, you've got more memory, up to 128 gig of memory you can use, various different networking modes, so it's not the same kind of way, but if you need the flexibility of the networking, serverless containers is going to be useful for you. And unlimited running time, so you're going to run these stateful services that are going to be running your web requests or draining some kind of queue or running some kind of database. Unlimited running time is going to be useful for you. And multi-concurrency, so you can be able to route multiple requests into a container, which is going to be better for your throughput if you want to have that. So in terms of the costing models, these are sort of two different ways to think about it. Fargate is you pay for what you provision. This is a container. You say, I want this container provisioned, and you're going to pay for that regardless of how many requests are going to come in until you stop that container. And so you can, if you can be a bit dynamic, you can use Fargate Spot. I mentioned earlier, you can, when we've got unused capacity, we can make that available for a period of time, and we will notify you to say, your Fargate Spot instance, I'm sorry, we need that back for a minute or two. But if you've got an auto-balanced website or that kind of thing, you can just move that over to another container and take advantage of that pricing. Obviously, you wouldn't want to be using Fargate Spot if you've got one container running a database, and we said, oh, we need to take your database instance down in a minute or two. Probably won't make you happy. So again, architectural choices. So if you have high traffic, your code is efficient, and you want the lowest per request cost, then Fargate's going to be the one for you. Lambda is pay for what you use. So literally, you pay for per millisecond for the exact time that your function is going to run. You have a single request come in for a Lambda function. If you don't have another request, it just pauses there, doesn't do anything, doesn't charge you anything, really simple. Next request comes in, and then you start getting charged. So you literally, when there's gaps for the work to do, it's really going to be cost efficient. It's going to scale with that graph really easily. And so, yeah, a really easy way for you to understand your costs for your application. So, when would you use containers? If you need lowish startup latency, not as fast as Lambda, but you're still going to be able to scale up your containers. Anything that needs more than 15 minutes, if you've got predictable high traffic usage, you're running a very high performing website, that's going to be it. Data persistence as well. If you're going to be able to create a block volume or something that you can map it to your container instance, that's going to be a consideration as well. And yeah, when you actually need control over your compute environment, if you want to pick different instance sizes, you want to mix and match them, you want to have more control over that, and also your tooling consistency. These are Docker containers that you can run on your laptop, you can run anywhere else, you can run it from a Raspberry Pi to multiple cloud providers. This is going to give you that flexibility to use exactly the same kind of tooling. Lambda on the other side, we saw the scaling. When you really need immediate startup time, you want to trigger your function to run based on an event. Varying utilization, you can't really predict what's going to happen. This is going to be the really good service for you. You don't know what your demand's going to be. Lambda's just going to figure that out for you and handle it for you. Again, from an architectural things, when you want to just make fewer decisions, you don't want to have to decide on various instance sizes and how you're going to fit that all together, doing your network egress and handling all your load balancing and all that kind of thing. If you're happy for AWS to look after that, that's going to make Lambda a really attractive, where you can hand over that operational complexity for us to look after, and you can look after your code. So there's a sort of sweet spot where if you've got a lot of requests and you've got a sort of lot of stable and predictable workloads, then Fargate is going to be the best for you. But if you've got varying workloads, you're not quite sure, spiky on-off hours, you're not quite, you don't want to have to manage that, Lambda's going to be really good. And Lambda's not going to be as resource and cost efficient if you're going to be handling many thousands of requests, but otherwise it is still going to be able to scale up for you. So again, a lot of words. If it's simpler, if you've got something that's long-running, stable, lots of high volume, and high resource event sources, ECS Fargate is going to be super useful for you. And then, for most other workloads, certainly look at Lambda. But this also brings up the bigger picture of but I can't do serverless because there are lots of other considerations that you can think about. Now, I appreciate I work for AWS, and you think, well, of course he's going to tell me all about the AWS things, which I am. But these are some of the common objections that people have for serverless. Well, it's not for production usage. Sure, my sort of little test and development accounts, and I've got a little bit of code. That's fine. Well, we've shown here, whether you run a function in a test environment or you run it in a production environment, that scale is going to happen exactly the same way. We scaled up to 10,000 requests. If you had a production application handling over that, I just created a demo here. It took me a couple of seconds. 10,000 requests going to a Lambda function. That's pretty good for production workloads as well. Because AWS is handling a lot of the work behind the scenes, it means it is built for the most demanding production workloads. It's different. Yes, appreciate serverless may be different. There is a bit of a learning curve that you need to do, but that's with all things in technology. If you're building a new framework or using a new framework or a different computing service or a new database, there is stuff to learn. So, I would take that as a bit of a challenge, that it's a new architectural thing to learn, but it's certainly going to pay dividends, because once you've learned these things once, they're going to be more applicable. I think the scaling, we can knock that on the head, because our Lambda functions can scale pretty high up. The containers services can scale even higher up as well. So there aren't huge amount of workloads that happen in the world that don't run on serverless because of a scale. Cost certainly can be a concern. People are very worried about the ways that costs can scale beyond their usage, because, oh, isn't it great that a Lambda function scales for my usage, but what happens if my usage goes off the charts? What's going to go on? So first of all, that may be a good thing. If your application is super busy and you've got lots of customers hitting your website, you want that scale, and so you're happy to absorb that cost because they're hopefully generating revenue. But you don't want it to run away. So there are some cost controls. There are ways that you can limit your Lambda functions. There are ways that you can understand what's going down. You can sort of protect your resources and constrain those kind of costs, which is, of course, very important. We don't want to have runaround costs. Another one is the lock-in. Like, oh, you're using AWS. I'm all going to be locked into using AWS. How does that work? Well, two takes on that. You're always going to be locked into somewhere. Whether if you decide to pick Java as a programming language or Python as a programming language, you're not going to switch between the two very easily. Also, with Lambdas and containers, I think you've seen there, it is your code. It's running in Node, Java, Python, whatever. It's your code. That code is entirely portable to any other kind of service. Using our container services, it is a container. You can pick up that container and run it anywhere else. Where the lock-in does happen is we are going to run the infrastructure on your behalf behind the scenes, but if you're going to pick up your application and run it somewhere else, you're going to then have to build that infrastructure. So you not locked into your programming language of choice. You can use that, any language that it's just normal JavaScript code, for example, can move it anywhere else. Where you are locked in is using our infrastructure and our hardware and all that kind of thing. And so you move it somewhere else, and you're going to have to build with that. But you know, that's building more. You're not having to sort of reinvent the wheel for doing that kind of thing. And the other kind of one is it is a slight different developer experience. You're going to have to learn event-driven architectures. You may have some different tooling if you're going to package things up. You know, files maybe need to be in a different location. You've got to understand a bit of load balancing. But again, as with it's different, this is just a different way of building applications. And you know, certainly the kind of thing is when you're building serverless applications, they're always improving under the hood. So AWS behind the scenes is we're going to build well-architected fundamentals. That means best practices. We build them securely. We're going to always improving the developer experience. We're going to have more controls. We're going to have more ways that you can do it, higher scale, you know, hopefully cheaper costs, better integrations. So once you start building serverless applications, you will understand that behind the scenes, some things just get better. They get faster. You get more integrations, and you don't have to do anything. And that's the whole premise of serverless. So it's a bit of a whistle-stop tour through some of the architectural patterns about using serverless compute. I'm going to be on the AWS booth all today. We've got a demo application. You can come and even get some free coffee. Happy to talk about all the kind of things. And thank you to GOTO and the other sponsors and the organizers for putting everything together today. It's a lot of work. And thank you for coming, most important.